Chapter 5.1, Polynomial Functions. So really this section is just going over the introduction to what are polynomials and basic vocab. So some basic vocab. Monomial means when I have one term. Example, if you look down below, the ones that are monomial here are these right here. The reason why there's monomial is because there's only one term. There's no adding or subtracting. This would be called a binomial. Bi means two. The reason why this would be two is because there are two terms here. Two things that are separated by adding and subtracting. Degree of monomial. If you look in this first column, this gives you the degrees of all of these. If monomial has a degree of 0, that means that there's no variable there. So since there's no variable, it's going to have a degree of 0. This has a degree of 1 because there is 1x. Now if you look further along, this has a degree of 4 because of the fact that the highest degree here, or the highest exponent of the variable is 4. So that's why it has a degree of 4. So I'm going to talk about polynomials. Polynomials is just basically a word we use for any type of function that has more than so many terms. So in this case, this is a polynomial of 4 terms. So whenever you see anything that has adding, subtracting, you can always consider it a polynomial. So the degree of the polynomial is always looking at your variable that has the greatest exponent. So this has a fifth the degree because this exponent, the highest exponent, is 5. So again, a polynomial function can be any set of terms. Terms are the things that are separated by adding and subtracting, and those would be polynomials. So we have to write this in standard form. When you're writing in standard form, you want to have the highest degree first. So the highest degree is always the exponent that is the highest. So in this first one, my highest exponent is x squared, so that should come first. And then my next highest exponent is just the x, so I put plus 3x plus 5. This right here would be in standard form. And the classification of this would be the degree would be 2 because my highest exponent is 2. And you call this a binomial. So the second one, my highest degree here, if I look, is this 4. So I'm going to have x to the 4th first. And then you go down in terms. Now the next one I have is squared. However, there's 2 squared, so I'm going to combine like terms. This would be plus 4x squared. This is a negative 6 plus 10, that gives me 4. And then I have a 4x, so I have 4x, and then minus 12. This right here would have a degree of 4. Two other things that we have to know about polynomials. Again, they're just functions. End behavior. End behavior is saying, what if I plugged in at negative infinity, what would the left side of the graph would look like? Or what if I plugged in infinity? Basically, that's what end behavior is. In this first one, it's up and up, meaning if I went all the way negative, my arrow is pointing up. And on all the way positive, my arrow is pointing up. Here's down and down. And again, this is an example of the equation that would follow that. So on down and down, that means both arrows are pointing down. Down and up. That means on the left-hand side, it's pointing down, and on the right-hand side, it's pointing up, and up and down. On the left-hand side, it's pointing up, right-hand side is pointing down. Turning point is exactly what it says. Turning point means what if I was on a roller coaster, and then I hit the highest point, and then I went down, and then I went to a low point, and then up again. Whenever you change directions, that's going to be a turning point. So if you look at this first one, I have a turning point at 1, 2, 3 spots. Here I'd only have one turning point. In this case, I don't ever go down, so this would be no turning point. And the last one, here's a turning point, and here's a turning point, because I'm going down, and then I'm going up, and then I'm going down. So this is just by general rule what equations typically look like. If I have a degree of 1, so it's just if I had an x, this is usually what the equation looks like. You have seen this before multiple times. This is a parabola, so that would be if I have a degree of 2, it would look something like this. In this case, I have a degree of 3. Now, the difference between these two equations, they both have a degree of 3, but this one has 2 turning points. So how would you get that? This is the parent function of x cubed. This would be something as if I had x cubed minus 4x squared plus x minus 10. That could be the equation for this last one. Consider the leading term. So the leading term is always going to be the term that has the highest degree or the highest exponent. For this first one, 4x cubed is going to be my leading term. What is the end behavior? Now you can always check this with your graph, but basically if I plugged in a negative infinity, what would this number be? Well, whenever I have something cubed, a negative times a negative would make it positive, but then multiplying by a negative again makes it negative. So my end behavior, if I went to negative infinity, I would end up at negative infinity, so that would be down. And then if I think, what if I plugged in infinity? So if I plugged infinity in here, that infinity and times infinity is infinity. Times it again, it's still going to stay positive. So then I would go, oops, I'm going to change colors. Going to be positive, so that would be down, up. So for the second one, this is my leading coefficient. If I plugged in a negative infinity into this equation, any even exponent right here is going to give me a positive number, but then I multiply it by a negative 2, so then it would actually end up to be a negative number, so this would be a negative infinity. What if I plug in a positive infinity? Well, any positive number raised to the fourth is still going to stay positive, but again, I'm going to be multiplying it by this negative 2, so it's going to end up to be negative infinity, so it would be down, down. And you can always check your work by using the graphing calculator. So if you were to graph these, this is what it would look like. Now if you look at this first one, this would also, if I asked for the turning points, this would have 1, 2 turning points. And the second one, this has 1, 2, 3 turning points. So that is all for this video. So basically just some vocab on what polynomials are and certain things that we're going to be talking about throughout the whole Algebra 2 career. Have a great, grand, wonderful day.